Welcome back to the channel. So today we will be solving this is subsequence DSA problem. It is an easy category problem, but very famous problem. You will see this question in almost each and every interview. And let's read out the problem statement. Given two string s and t, return true if s is a subsequence of t or false otherwise. So we need to check if s is a subsequence of t or not, right? So we have been given two string s and t, and we need to check. So if you can see the input and output also, like we need to check if s is a subsequence of t or not, right? So let's understand like what is subsequence or not. So basically this is the same thing. I will explain in much better way. So let's read what is a subsequence and what is a substring, right? What is a subsequence and substring? So before understanding what is subsequence, let's understand what is substring. This is the definition of substring: a contiguous sequence of elements that appear in the same relative order as the original string, right? Contiguous sequence of symbol. So here it is a contiguous, right? But here it's not necessary that it should be a contiguous, right? But the element should come from the target element only. So if you see like in substring, so if you see here code, right? The string code is part of this string T, and the code like the each and every character from this S string appears in the T string, but all of them are together, like they are contiguous sequence of element. But if you read out the sequence, a sequence that appear in the same relative order, but not necessarily it should be contiguous, right? So let's check the example. So if you see A, B, C in the S and A, H, B, G, D, C, like we have these two strings, but if you see this A is here, this A is also here, this B is here. Let me zoom a little bit, right? So if you see here, A is here, A is also here. Then in the S we have B, but in the T we have B, but it is not like contiguous, right? We have H in between. Similarly, here we have in S we have C, but in the T we have C, but it's not in a sequence, right? It is not in a contiguous sequence. So, but we can say this is the like the S is a subsequence of Ty, because each and every element of string S is present in T, and that too the relative order is also same, right? Relative order is also same. It's not like so. In this like what is the meaning of the relative order, right? The same relative order. Let's say if I have an element, right, like this A, C, B, right? So if you see A is also here, C is also here, B is also here, but this is not a like a subsequence. Why? Because the relative order is not getting preserved. How? If you see here, A is like in the inputs, like in string S, C is before B, but in the output over here in T, C is after B, right? So we cannot see this, we cannot say that these two string are subsequence. Got it? Like you now understood what is subsequence and substring, right? Okay. So let us take this example and try to understand over a on this, right? So let me delete this. Let me paste that. Okay. So we have these two string, right? So for this question, what we will do, we will be using two-pointer approach. We will be using two-pointer approach. Okay. So let's see how we can solve this. So in S, let me increase the this thing. In S, we have A, B, and C. And in T, we have A, H, B, G, D, C, right? We have this. Let's give the index also 0, 1, 2, here also 0, 1, 2, 3, 4, 5. Okay, and now let's start. So what we will do, we will be using two pointer approach, right? We will keep one pointer at here at the ith index, and we will name this as I, and it would be at 0. And here also we have j, and it would also start from 0. And we will check if a if s of I is same as t of j. Are these values same? Yes, these are same. So what we will do, we will increase both the pointer, right? Because they both are same, right? So we will increase both the pointer. So let me change the color of the pen. Let's keep red, right? So j will come here, I will come here, and j will be also here, right? And then again we will check if b is same as h. No, it's not same. So what we will do, since we are looking if s is present in t or not, so we will increase on the j pointer, right? It's quite simple to understand, because if we increase the I pointer, what will happen? We are not checking then b, right? We are not checking then b. We will skip that. So we will increase j here. Let's see if s of I is same as T of J. Yes, they both are same, right? They both are same. So what we will do, we will increase both the pointer. So I will come here and then J will come here, right? Similarly, we will check if S of I is same as T of J. Are these two values same? No, they are not same. So what we will do, we will increase this pointer, not this pointer, right? Because we are checking if this is present in here or not. So we will increase this also. So j will come here. Then again we will check. This pointer will be here, right? This we are not moving. So we will check if s of I is same as t of j. Are these two values same? No, they are not same. So what we will do, we will increase the j pointer, and j will come here, right? So are these two values same? Yes, they are same. So what we will do, when they match, we will increase both the pointers. So I will come here and it will come to index 3, right? It will come to index 3, and this will also increase. So this will come at index 6, right? J will come here. J will come here, right? So if you see, we have like covered each and every element from S. What it means, if I reaches to the end of the string, that means we have found the element. Like the this string is subsequence of this string, right? So we will return if I is equal to length of S, right? Whenever this case meets, which means we have reached to our destination, right? So let me delete all these things and let's do the dry run with the code. Okay, let me bring the code over here. So this is the code, right? Let me grab this. Um, okay, let me zoom out a little. Okay, let's paste it here and let's understand. Okay, so as I mentioned, we will be having two pointers, right? Okay, I don't know why it is not getting selected. Yes, we will be having two pointer, one I equal to 0, j equal to 0, right? One pointer here, one pointer here. And then we will have n, which is the length of string s, and then we have m, which is length of string p. and these two cases are there. So let's say if length of n, like this n is 0, what it means? The length of s is 0 and empty string is always a part of the another string, right? So this would be true case. And what if the m is 0? So what is m? M is nothing but the length of this tree string. And if it is a 0, that means what? Like this string is empty and this can be anything. So if it is anything and this is like empty, then it always be false, right? It always be false. So these two like special cases we are handling over here. And then we have this case, right? I is less than n and j is less than m, right? I should be like this is the boundary condition. And then we are checking if s of I is same as t of j, similar how we did, right? We keep on checking, and if they both are same, then we are increasing both the pointer. If like they are not same, then we are only increasing the j pointer, how I showed here, right? We are only increasing the j pointer because we are looking if C, like if S is present in T or not, like, right? We are not checking if T are present in S or not, right? So that's why we are increasing j pointer. And this is the condition, like in each iteration, we will check if I is same as n. If it is same, then and there we will return true, right? If I is equal to n, then we will return because we have already covered each and every element of S, right? And if this condition doesn't trigger, then it is false case, right? Like the element is, that means that S is not a subsequence of T. And so what is the time and space complexity? Let's discuss that. Before that, let me clean this. Okay, so let's discuss time and space complexity. Okay, I know why the size is very less. Okay, let it be. Let's write with this one. What is time complexity and space complexity? So time complexity would be like we are at most we are iterating the entire like length at once, right? We will be iterating entire length at once, and that too. Uh, so the time complexity would be O of length of the T string, right? The T string will always be bigger than the S string, right? And that too, we are checking only in, we are checking if S is present in T. So this would be length of T, right? So this is the time complexity. And what is the space complexity? It would be O of 1. Why O of 1? Because we are not using any of the extra space. As you can see, we are just simply using few variables. So yeah, we have solved this question, right? So if you like this content, do like, subscribe, and share the channel. And if you're new to this channel, so you can check out the channel. So basically, you will find a lot of PySpark, Pandas, SQL, interview questions, right? So until then, bye. Take care.